Today I will discuss the concept of array and linked list. So what is array? Array is a data structure which can store multiple data. That is, this is an array. It can store 5 data. And we have to decide the size of the data at compile time. So it is fixed length and it uses same type of data. It cannot contain different types of data. For example, if it stores integer type of data, it will only store integer type of data. It cannot store the string type of data. And it is contiguous allocation of memory. So it allocates the memory in continuous location. So it is, if the size of the data is 4 byte, and for example the size of this cell, the address of this cell is 0, so this cell will be 4, this cell will be 8, this address of this cell will be 12, the address of this cell will be 16. So this is contiguous allocation of memory. Array can be of different dimension. So this is 1-dimensional array, this is 2-dimensional array, and 3-dimensional array will contain these tables multiple times, and 4-dimensional array will be multiple types of 3-dimensional array. So generally array index starts from 0. So here array 2, this means this is a single dimensional array. So 2 means 0, 1, 2, this index. So this will retrieve 24. This means this is a two-dimensional array, and 1 means 0, 1, second row, and third column. 2 means third column. So this will retrieve this 20. And 3, this means 3-dimensional array, where this means the second table, second row, and third column. So this is how we can calculate the index and the value of each cell of the array. Array uses less memory and it is of fixed size. We can access the data randomly with the index, and it is useful when we know the size of our data that is needed in the program before the compile time, and we have to do complex calculation on the data. So this is there, the array is useful. Now linked list. Linked list will look like this. Each of this is called a node, and each node is linked to other by storing the address of the next node. So each node contains 2 parts, that is data and the address of the next node. This is data and this is the address of this third node, and this is how it goes, and the final node contains null. This means this is the end of the linked list, and this cell is called the head cell. This is the first cell, and as this is linked list do not maintain the contiguous memory allocation, so it is non-contiguous memory allocation, and so it is needed to store the address of the next node. Linked lists do not allow random access to any cell, so we have to go through the head node. So first we have to go through this node, then we got the address of the next node, then we can access the data of the next node, and then we again find the address of the next node and we can access the data, and then we find the address of the next node, and then we address the data. So if we have to access the data of this node, we have to go through this. There are some way to make a linked list two-way, that is two-way linked list. This means each node contains 3 cells. First cell will contains the node address of the previous cell. So here for the first node it will be null, and then the data, and then the third cell will contains the address of the next node. Here also there will be 3 cells. First cell will contains the address of this head node, and the last cell will contain the address of this cell. Here also there will be 3 cells. First cell will contains the address of this cell, and this cell will contains the address of this node. So here goes on. So in two-way linked list we can traverse reversely. So we can start from the last node and we can traverse reversely with this previous node, first cell of this node. So we can get to this node, and the first cell of this node will indicate the address of this node, and so on. It is useful when we have to use long and dynamic size of data. We cannot decide the size of the data before compile. So in linked list it is easy to dynamically change the size at runtime, and as this node is separated from this node, so this can contain different types of data. So this may be integer type data, this may be string type data, and so on. This may be float type data. So there is no restriction of using same type of data in a linked list. Now the difference between array and linked list. As we said, array is fixed size. The increment of the size of array will be difficult in runtime, but linked list is dynamic in size. We can increase the size or decrease the size at runtime easily. It allows contiguous memory allocation. It allows non-contiguous memory allocation. It uses less memory, that it only saves the data, and linked list uses more memory as it saves data and address of the next node. It allows direct access to any data through the index, but in linked list it is needed to start from the head node to go or search for a specific cell, specific node. Array is not dependent on other data, as we can have direct access with the index, but linked list is dependent on previous data, because previous data stores the address of the next data. So today is up to this much. If you have queries or need any detail, let me know in the comment section. Thank you.